Radiation flux. Flux normally stands for number of electric lines of force or magnetic lines of force. Sometimes this term flux also represents the rate. Like when we talk about flux while studying hydrostatics, there we mean rate of flow of volume or rate of flow of mass. Likewise, here also, when we are saying here radiation flux, that means the radiation energy transmitted, emitted, proceeded per unit time. We know that when charges are accelerated, they produce radiation energy, electromagnetic energy. That radiation flux is given by this q square E square upon 6 pi epsilon naught c cube. The terms are usual. Q is the charge, E the acceleration, and C the speed of light in vacuum. You see, when electromagnetic waves travel in free space, even there also they are subjected to some kind of hindrance, and the concerning impedance is given by root mu 0 upon epsilon 0, and that amounts to about 377 ohm. We would say the impedance offered by free space in the propagation of electromagnetic wave is equal to 377 ohm. One thing is also very important to be noted, that when electromagnetic waves travel, the direction of their propagation is given by E vector E cross vector B. Now, in the same pattern, we are going to define pointing vector. Pointing, Pointing, pointing name of a scientist, pointing vector. It is in fact the energy traveling per unit area perpendicularly per unit time, that is called pointing vector. This is given by E cross pointing vector. In certain books, you'll find this given by P also, and this could be written as E cross B upon mu naught. E electric vector, B magnetic vector, and divided by mu naught. You see, E, that's RMS value, that is equal to E naught upon root 2. Similarly, here also B naught upon root 2. That way you could say it is upon root 2 2 times, that's going to be equal to 2. So it becomes this thing. You also know C equal to E naught upon B naught. So we can replace this B naught by E naught upon C. This is 2 mu naught E naught upon C. E naught square upon 2 mu naught C. It's written over here. Similarly, if you want to replace E naught in terms of B naught, you are going to get this result. Now, finally, while winding this chapter, electromagnetic wave, you must come across electromagnetic spectrum. You see, I have already clarified that apart from three forces, all the forces are called electromagnetic. Three forces, that is gravitational, that is weak nuclear, and that is nuclear force. Three forces you exclude, all are others electromagnetic force. And correspondingly, electromagnetic waves are responsible for their interaction or the existence. Electromagnetic waves have a very wide range, starting from gamma rays. Gamma rays, these go up to radio waves. You see, here we have chosen the term in terms of ascending wavelength. If you start from here, from radio waves to gamma rays, it is in terms of descending wavelength. Gamma rays, then X-rays, ultraviolet, visible, infrared, microwave, and finally radio waves. Separately, we have given their details. Gamma rays are mainly used in the treatment of cancer, and X-rays are used for diagnosis, that is finding or detecting the bone fractures. Shadow photography is used as a principle in detecting through X-ray. X-ray is also useful in the treatment of cancer. Ultraviolet radiation, these are used in preservation of foods, stuff, and study of molecular structure or their electronic configuration. If some forged documents are there in the offices, it could be easily detected with the help of ultraviolet rays. Infrared radiations are especially known for their heating effect, but along with that, these are widely applied in maintaining the temperature of greenhouses, in detecting the writing of older scripts. Their depth could easily be detected with the help of infrared radiations. Microwaves are used in food processing, in heating, cooking, etc. Radar also work by using microwaves, and radio waves finally, are used mostly in radio, television, and overall in communication field.